So I was going to share my own observations about the topic of perspective. It's the origins of perspective. I'm drawing this with a marker because there's nothing with my computer that that's like a good enough tablet like I'm drawing. Okay, so let's say we have a screen of some sort, and you have an object. Okay, so ordinarily you have like a light source. You know, so light source is putting out light rays, all kinds of light rays. And some of these are maybe bouncing off of here and going onto a surface, right? And what we have here is this phenomena is not really perspective. What this is more like radiosity. So if you have like a light bulb right here, say you have a light bulb right there, and it's putting out light rays, you're just going to have a brighter area in this region here. So this region is all brighter. But that isn't really what you would consider perspective. And really what perspective comes from is this thing we have an eye, right? Comes from really the hole in the eye. So what happens is, let's say we have, well, you know, like an eye is like this, and there's a little hole. Let's say there's a hole right here. So what's happening is there's a number of light rays that are going in here. What's happening is that there's light rays all over the place, right? They're going everywhere. But if you hit this particular spot, you only get a point on here which corresponds to the opposite of the originating point. So let's see. I guess I'd have to draw two. So there's a point there. So that would hit there. Depends. You have to describe where these all are. Okay, so any point here corresponds to a specific point that exists out in the world, right? It's a ray from this point out to the world. Okay, so I've drawn some originating points and their destination points through a pinhole, right? Through a small hole of some sort. And I left these ones here so you could see where those go. But again, this is because only the light rays that intersect with this point will continue through and produce a point on the other side, which is the opposite of the angle from the inside. Now this means in the case of an eye, this means in the case of an eye that there's your pinhole right here, is that this is here. So this is going to be an upside down image of the same thing, right? Or sorry, it'll be inverted. The output image will be inverted from the input image. This is the plane that is receiving it. This is the one that has a perspective. In fact, this is, again, perspective is a result of a pinhole projecting out into the world all the angles that are incident to that pinhole. So that's really where perspective is coming from. And the perspective, again, is just the idea that every point in space is the result of a ray coming from that pinhole. Okay, so in terms of how the computer figures this out is it uses something similar to an eye, but it just puts it in front of the point. Let's say you have an object like a box, right? And then the light rays are going to this It's right here. Okay, this is the picture plane. So this would be what you're seeing on a computer screen is the picture plane, right? Now, if you're actually thinking of the picture plane in terms of the screen, computer screen, you could say this is the X direction. This would be like a Y direction. Okay, so let's say you're trying to find where these points are on here, and this is an orthographic side view. So really, let's just say that they're going to be here, but you don't really know on your computer screen. Okay, so what happens here is you can take this as being 0, for example, it's below the ground, above the ground. Then you have something like that could be A, this would be B, this spot here to here, that would be B. Okay, now if you talk about this distance here, this could be B prime, and this would be A prime here. And since these are similar triangles, A prime is to B prime as A is to B, right? And you're trying to find, in this case here, A would be this way. You'd have to do the same thing the other way to find out where the point is on the other direction. But then you can say A is A prime B over B prime, right? So in terms of this, you have to figure out, you have to define these as points. And this is where computers is different, because computers, everything already has an X, Y, Z point, right? And usually you say Z is corresponding, it was not, you don't ever talk about this as a Z direction, but usually you think of down in the, it depends on how you want to do it. If you want Z to be into the plane, I've seen some ray tracing programs that are like that. But, I'd usually think of this as a Z coordinate right here. So this would be like Z equals 0. And then this would be like point, whatever it is, so many in what direction. Then you take the relevant ones and plug them in here, knowing these values, and you get this one out here. And then this, the distances here have to do with how far this picture plane is from the origin. You call it, I think, focal length is the distance from the converging point to the picture plane's focal length. Okay, so let's say you have a picture here, which is a perspective picture, and we'll put the horizon here, and we'll draw a map, an overhead map of the thing that we're drawing, right? So let's say, okay, that's a picture plane there, and we'll say there's a box here and another box here, right? So what happens is you can see these are the light rays, right? So let's say your first box is here. So this is what your first box would look like in the perspective image. This is like a 3D view, I guess, right? So this is the first box here. And you see, since the light ray here is, since further away objects cause smaller points on the picture plane because the light rays are thinner, that means that your second object is going to be smaller, right? Okay, so you can make the general statement, and the way it works out is that basically as you approach, the objects get further away from the focal point or picture plane. These objects get smaller and smaller, right? So it's just generally things that are further away are closer to being on this horizon, not being objects, right? Also, if you have an object which is like let's say we're looking at the top, that's like a piece of paper. So there's your piece of paper. If you rotate it to collinear to the light ray, it's going to become closer to being a, let's put it here, closer to just being a line, right? So that would be like a piece of paper that's mostly in the same direction as the light ray going to this point. Right. So again, perspective is, I guess, nature's way of scanning an environment, because you're gathering information about all things around you. All these points represent something somewhere out in the world, right? Okay, so let's say this is a perspective image, and let's say you're looking at the top, and you have, again, this is your picture plane, and you have maybe a box of some sort, right? And the box here, all the edges, this plane here is all the same distance. Everything on this plane here is the same distance as here. So anything with a plane that's totally parallel to the picture plane is going to be just a straight line, right? So what's true is that you call this one point perspective, and you would say that the vanishing point is there. And the vanishing point just comes out of what perspective is, but it's true, right? You see, it was typical of one point perspective. You see it's a geometrical condition where you're dealing with planes that are parallel to the picture plane. So you get this hallway, so you get like maybe columns coming out of here. You see this a lot. You see stuff like that, maybe doorway, hallway, right? So that's one point perspective. 2 point perspective happens when you have an object that the planes are not parallel, but how can I say, the planes of the object are constant in this direction, but not, or in the vertical in that direction, but not in this direction. So it's rotated, but it's not rotated in the other direction. So in that case, okay, so again, in the case of a two-point perspective, an object whose planes are rotated so they're not parallel to this plane, but their vertical remains constant, then you wind up with something which is like, let's see, like that. Then you would say this has two vanishing points. Okay, and what happens is when you have it rotated like this way, so it looks like kind of like that in plan or something, then you wind up with something which is like what's going on here? You wind up with something like that. Didn't draw that really that great. Okay, and then these here, these actually might go, let's see, this go to a point which is, I think, similar to those, but they're on a different, they're different elevation. Then you get another one here, which is down here somewhere. So the way it's usually been done with computers is, say you have your, try this in maybe 3D here. There's your picture plane, there's your focal length. So let's say you have, say a box out here somewhere, right? And it finds a point on there, and it's going to try to say, is that point being illuminated by a light? Right, so the light's getting off rays in all directions. So they're going to be concerned with, is there like another object between there? If there isn't, that's a shadow, so you won't have any light, for example. So it basically, with ray tracing, usually you find a point on an object, then you try to figure out if you have a condition where something has lit it, or there's a reflection from something reflective, perhaps, that's gone to it. So you have to check out reflective surfaces. You have to check out if something's in the way. You have to check out the angle. You see if it's relative to the light ray coming from that thing. If the angle is 100% or a certain percentage, so that would produce a shading, right? Okay, this is just one last example I did using my computer here, and it's really better if you have a straight edge. But what we're doing here is you take or two orthographic projections, you get heights from one, the other direction, and you try to regress them back into perspectival space using a overall perspective reducing vanishing point, and then you have some vanishing points for other related angles, and then you can somewhat derive a image out of that. So today, computers do most of the stuff, and I guess it's a lost skill, but it's a highly repetitive issue with this. Again, this translating into the perspectival space, and then the intersection of various points. So computers just do this today, and I'm not really. And also, computers do material rendering, and these are sort of things that are sort of difficult to do in traditional drawing.